Welcome to today's class. Today, we will learn the basics of pipeline isometric drawings. Pipelines are known as the arteries of petrochemical production and are crucial components of chemical equipment in petroleum and chemical industries. Process gases, process liquids, and fluids such as water and steam in the production units are transported through pipelines. Connections between chemical equipment and machinery are also achieved via pipelines. Correctly identifying pipeline types, connections, and layouts. Understanding the structure of common valves in chemical pipelines, as well as proper installation, operation, and maintenance, and accurately interpreting chemical pipeline isometric drawings are essential professional skills for frontline chemical production operators. Pipelines layout design drawings include piping layout drawing, plan layout drawing, elevation layout drawing, sectional layout drawing, pipeline isometric drawings, piping component diagrams, and pipe support drawings. Our focus today is on pipeline isometric drawing. Next, let's explore the definition of pipeline isometric drawings. Pipe isometric drawings, also called spool drawings or empty state piping diagram. They illustrate the special routing of pipelines from one piece of equipment to another, or the directional layout of a pipeline section within a specific area, along with a 3D arrangement of attached fittings, valves, and instrumentation. Here we see the isometric drawing of pipeline segment as shown in the figure, which clearly shows the spatial routing of this pipeline and the installation positions of its fittings and valves, drawn using isometric projection principles. They offer strong 3D visualization and readability, thoroughly and clearly reflecting design and construction details, and help identify potential design errors, preventing issues like empty state piping diagram, pipeline clashes that are not easily detectable on the drawing, thus facilitating prefabrication and accelerating installation. They are a critical method for equipment and pipeline layout design and represent the trend in pipeline design development. Next, let's examine the projection principles of isometric drawings. Common types include isometric and oblique diametric projections, but we focus on isometric projection here, as shown in the diagram. Pipelines isometric drawings use isometric projection, where the three primary axes of an object are equally inclined to the projection plane P. Parallel projectors perpendicular plane E cast the object onto P, resulting in an isometric projection, abbreviated as isometric drawing. Next, we'll learn two key concepts of isometric projection. First, axial angles in isometric projection, as shown in the figure. The O sub 1, Z sub 1 axis is typically drawn vertically, while O sub 1, X sub 1, and O sub 1, Y sub 1 axes form 30 degrees with the horizontal line as shown. Second, axial scaling factors. The scaling factors for X, Y, and Z axes are 0.82. For simplicity, they are often set to 1. Known as simplified scaling factors. Axial lines in the drawing can be measured at actual lengths. Finally, let's review the contents of a pipeline isometric drawing. It includes, first, graphics, symbols, and graphics of the pipeline, and its fittings, valves drawn using isometric principles, second dimensions and labels, pipe numbers, connected equipment tags, nozzle IDs, and installation dimensions. Third, the orientation symbols, a directional reference. Since the drawing uses isometric projection, its orientation must be defined first as shown. The primary reference is the plant north, aligned with the PN. In pipeline arrangement drawings, with the orientation mark placed at the top right of the drawing. Fourth, technical requirements, specifications for welding, pressure testing, etc. Fifth, material list, a table listing required piping material, sizes, specifications, and quantities. Sixth, title block includes name, number, and responsible parties. Through this lesson, we covered the definition of pipeline isometric drawings, their projection principles, and their contents. We hope you understand and master these concepts.